So I wanted to do a video about a technique that I will be using to avoid fixing faulty genes in my new breed. Um, so I first need to define fixing. In each breed, there are traits that are possible and there are traits that are impossible because the gene pool is limited to certain genetics. So, for instance, I don't know, Great Dane, couldn't produce a Chihuahua-sized dog. Okay, they don't have the genes in place to produce small offspring. And the same is true for Chihuahua. They can't produce offspring larger than a certain size. The traits for their size and their structure is fixed to a certain degree. And that can only be reversed by introducing new novel genes to the breed, um, which can be done with crossbreeding. So when we're developing a new breed, usually we start out with more diverse genetics and we end up with less diverse genetics. Because in order to get dogs that look really similar to one another, they actually have to be more genetically related to one another than dogs that are outside of the breed. Typically, a breed is developed by taking a dog with more genetic diversity and line breeding at some point, so that line breeding is when breeders breed dogs that are closely related in their immediate family, whether it's parent to offspring or siblings to one another. This causes the second generation to be much more closely related to one of the parents, and it can concentrate their genetics. So this is done to kind of, once you have a dog that you want to reproduce their traits in the offspring, and they're as close to your ideal as possible, you would find either a bitch or a stud that complements them in the areas you want to improve, or is as close as possible to your ideal. And then you breed them together. You take their litter and assess them how closely they are to the ideal. And then you would either breed siblings together or one of the offspring to one of the parents. And that can be done repeatedly. The problem with that is that it concentrates the bad genes along with the good genes. So there might be some really great genes there for appearance and for structure and for temperament, but they may not be great genes for aging or the other health aspects that are impossible to see and don't usually show up right away. If these dysfunctions show up after sexual maturity, after dogs have passed their breeding age, then it's already too late. They've passed on their genetics. And I think most dog breeders want to, reach their goal sooner. And it's not a common practice to do what I'm wanting to do, which is where you do line breeding to multiply your specimens with a certain trait, and then you pause on line breeding and you watch to see how that first generation develops. So you're producing a bunch of first generation crosses, basically. So I guess let me explain this in the example of Rihanna. Rihanna's got this amazing coat that I want to duplicate in all of my lines. But if at the outset I spread her genetics amongst all of my lines, then if it gets to the point where I realize that maybe she's got some bad genetics along with the good genetics, I've already spread her genes, and it's going to be much harder to eliminate those bad genetics. I'm going to have to bring up the example of the development of the Dalmatian. I may not have all my facts exactly right. I have a decent memory when it comes to gathering and storing facts, but my recall is really slipping as I get older, and so sometimes I'll remember something just a little bit wrong. So do verify everything I say and don't take it um, as a indisputable fact. Just a disclaimer. The development of the Dalmatian was done like most breeds before the canine genome was mapped, and so most breeds were developed without the benefit of the kind of genetic health testing that we're starting to see. They developed a certain look, which is, mostly white with large black spots. And they would select for the larger black spots that were separated with white space. And so eventually the breed got more of that look and less of the small spots that kind of blended together. And it wasn't until that ideal was widespread among the breed that they started realizing that there was a problem that they were all developing, and that is they build up uric acid, a byproduct of metabolism, and it creates kidney stones, I believe. And they were all developing kidney stones, and it was just such a prevalent thing that they realized that there must be something genetic. So there was one guy who I believe was, inspired to do an outcross. He used the breed, I believe, is a German wire-haired pointer, which is a dog that has small spots on its body. It's a similar gene, but it is not the same gene. And it's not capable of producing the large spots on a clean white background, but it can, produce smaller spots, which wasn't what they wanted ideally, but they were willing to, this particular breeder was willing to sacrifice that aesthetic feature for better health. And he approached the breed club about it, and there has been an ongoing battle over it in the breed club for, 50 years or something like that. And they're still not fully accepted in some circles. And that just really demonstrates how backward a lot of purist breeders are, because they're like, oh, introducing this German wire-haired pointer was diluting the purity of this breed. And it's a very racist type of mentality to talk about purity like that, as if having more inbred dogs means that they're higher quality. And actually the opposite is true. The more inbreeding that goes on in a breed, the more dysfunction they develop. So in my opinion, that was a brilliant thing to do and should continue to be done. And yet breed clubs are still resistant. And so do I care what breed clubs say? Do I care what the AKC says? No, they're just really ancient way of thinking about dog breeding that is, it's just not a modern way to approach it. The people who think outside the box, who are forward thinking like myself, are always ostracized by purists in the breeding community. And 99% of people in the breeding community are purists. And they believe in the fundamental belief that purebred dogs are inherently superior than mixed dogs. So once you understand genetics and the result of the coefficient of inbreeding going up, that thinking is incompatible. So dog breeds are inherently inbred. It's just what degree are they inbred to? And you'll notice if you look at the development of breeds, you will see this gradual shift over time to a more extreme look where they all look really similar and they all look much more different from other breeds. And this extreme type develops because they're concentrating genetics and they're losing genetic diversity as time goes on. problem with this is, I mean, just like we know when if siblings were to have kids in humans, they would have a higher likelihood of genetic defects. This is true in animals. It's just something that doesn't seem to be something breeders are aware of. But more relatedness is not a good thing. You can get a similar type if you're breeding dogs that have a similar type, but that are unrelated. So, for example, in the development of my breed, I'm using as wide a variety of breeds as possible, genetic contributors that all have similar features. You don't have to get a dog of the same breed to have a similar feature. So let's say I'm looking for a certain fur texture. There might be 5 breeds that can offer that fur texture. If I use all 5 breeds, I've added that much genetic diversity, and then I'm selecting for basically an expression of multiple genes in the dog. So the dog might have a length of fur that varies from, a standard length coat to a long coat. But the function is all the same. I'm looking for low matting, water resistant, cold resistant type coat, and that's easy to clean and low shedding. And I can do that by including many different varieties of genes. I think that the more broad the breed standard is, the more allowances there is in a breed standard for variations, especially in appearance, not in temperament, but specifically in appearance, allows for a much healthier breed, much more genetically diverse breed. So we talked about the development of the Dalmatian. It's possible for you to get a Dalmatian that doesn't have the problem with uric acid buildup, but it wasn't until the condition was widespread enough that they were able to even identify that there was a problem. And that is how genetics work. It's not until a condition is widespread in the population that they can start to identify what the genes are in play, and start screening for and eliminating from the breed. And what I am proposing is something that would prevent that from happening. So coefficient of inbreeding is a measurement of how related 2 dogs are. And you can tell that by lining up the genetics of 2 dogs and seeing which alleles they have in common. There's different versions of different alleles. Some genes might only have 1 version, but some genes might have 5 versions of an allele. And sometimes the change between alleles are really not critical. It might be just a variation in the fur color, for example. But others really contribute to lower quality. For example, let's say the gene codes for an enzyme that breaks down a metabolite in the kidneys, and when that gene isn't working properly, the process is slowed down or sped up to an unhealthy degree. And so there's only one really functional copy of that gene, and let's say the other 5 copies are less functional and 1 copy is really dysfunctional. That's how genetics work. Each allele, each spot on the DNA strand will have a lot of different options. The more options that you have to select for, the better health you can promote in your breed. If you only have 2 faulty genes to choose from on a certain allele spot, then your breed is automatically going to be either dysfunctional or more dysfunctional in that particular area. So what I'm trying to do is there's no way to look physically at the DNA and look physically at the allele and say, okay, this one is functional. You actually have to see the phenotype, the expression of the genetics in the dog as you're observing them. And this is best done as dogs age, because as a dog ages, it is harder for them to combat environmental stresses that cause the epigenetic effect of turning on faulty genes. There is a protective mechanism in genes that is constantly attempting to fix the genetic expression and turn off bad genes and turn on good genes. And in order for this process to work, there needs to be a relative limit to the amount of toxic burden the dog is carrying, and the reserve of micronutrients that cause the body to function. For instance, enzymes are created out of byproducts of vitamins and minerals, and they can't function without those. So if a dog is deficient in vitamins and minerals, certain enzymes and proteins are not going to function properly. And this process of patrolling the DNA to help the expression of the DNA to be optimized, that goes down. And that goes down with age, because dogs, refers to humans too, but dogs accumulate toxins and deficiencies or nutrient imbalances over time. And this is what contributes to the aging process. The genes start expressing more of the bad genes and less of the good genes over time. Also, genes that were not present in the genome at birth start to mutate over time. Mutations are happening all the time. Naturally occurring mutations in natural selection during the evolution process occurred very slowly, and the mutations were sometimes of a beneficial nature. However, we are in an environment that has an overabundance of mutagenic compounds, chemicals, and even elements. Elements are the smallest, molecules that you can find naturally occurring. And then you've got compounds that are combinations of these molecules. And then chemicals are just names of compounds that have a certain use. And we use a lot of chemicals in our modern day. Some of the most pervasive ones are pesticides. They're in our water and in our food and in our air. It's really no way to get around them. But unfortunately, a lot of them contain mutagenic compounds. You can find this online if you just search mutagenic pesticides. You'll find a list. These contribute to the development of new mutations. So the more this accumulates in our environment, the more quickly mutations are happening. And it may be at some point that they're accumulating so quickly that we can't combat them by careful DNA screening. But the way to do this is to avoid most of those compounds as possible. And I try to eliminate wheat, corn, and soy, because those are heavily processed with pesticides in, the factory farming process. As well as, even green leafy vegetables are highly sprayed unless they're organic. So it is incredibly hard to protect your dogs from this process that speeds up aging and just contributes to more the development of new conditions. But